Hello everybody, this is Rudra Pradhan here. First of all, wish you all very happy new year, and we are here to start our unit for lectures, that is on inferential analytics, and this is what the detailed structure. And in the last couple of weeks, we have already covered introduction to business analytics, exploring data and analytics on spreadsheets, and in the last week we have discussed descriptive analytics. So, now in the case of unit 4, we have inferential analytics, and that too we have two parts, inferential analytics 1 and inferential analytics 2. So, this week we will cover inferential analytics 1, and let me highlight what are the coverage under the inferential analytics. And before that, let us start with details about the objective behind this inferential analytics. So, here in this unit we like to understand the hypothesis testings and its importance in analytics, understanding to formulate null and alternative hypothesis, understanding concepts of significance, type 1 and type 2 errors, testing of hypothesis with respect to single samples, testing of hypothesis with respect to paired samples, and know the difference between the point and interval estimation. So, these are the details, the objectives, and corresponding to these objectives, and our unit coverage will be like this. So, the first one is a statistical inference, then hypothesis testings, test statistics, then confidence intervals. So, now today in this lecture series, so we will start with first statistical inference, and accordingly the highlights of the lecture will be statistical inference, testing of hypothesis, and knowing null and alternative hypothesis, type 1 and type 2 error, and estimating population parameters, and finally we will touch upon confidence intervals. So, then the structure will be like this. So, here the discussions will be on the basis of statistical inference. So, in the case of descriptive analytics, we started the discussion on the kind of problems and the kind of requirements, and in order to know the kind of problems and the basic kind of investigations, we have gone through various descriptive analytics structures, the data visualization, data analysis, and the kind of overview of the problems. So, descriptive analytics will give you some kind of inference to go for some kind of in-depth analysis, but here with the basis of descriptive hint and the kind of problem structures, we will go some kind of in-depth investigation process. So, as a result we have to know certain things, so that we can do the investigations and come to a conclusions as per the management requirement or the kind of management decision. So, in the kind of business analytics, we have a couple of things, and we try to investigate the problem under this particular umbrella. So, the first structure which you like to connect or like to know is sample versus populations, and then the statistical inference, statistics versus population parameters. So, now the idea is that we have a problems, then we have to investigate the problems, and there are various steps through which you have to do the kind of investigation. So, that may be transferred into modeling. So, it is the set of variable descriptions and the kind of functional relationship, and then with the help of data and with the help of the kind of structures. So, we have to investigate. So, since it is a question of data analysis or the kind of investigation with respect to data, so certain rules and regulation you have to follow, and on the basis of these rules and regulations you have to come to a particular conclusions. That means, we will get some kind of inference, and on the basis of this inference So, we have to go for some kind of decision, right. So, this is how the structure. So, here so we start with the concept called as a statistic. So, a function of random variables which does not contain any unknown parameters. So, that means, so when we will go for some kind of investigations. So, we have a variables and then the variables can be connected with a particular functional form, and in these functional forms. So, we have some kind of variables and then followed by some kind of parameters. So, we sometimes the parameters are unknown, and with the help of data and the kind of business analytics. So, we like to know the values of these unknown parameters. So, the business analytics will help you to obtain all these unknown parameters corresponding to a particular model and corresponding to a particular problem. And then once we get the parameters value, on the basis of parameters value and the kind of variable linkage. So, we like to go for some kind of predictive structures, and then we will go for some kind of prescriptive structures. So, here one particular structure is called as the kind of process. So, x bar, s squares, these are all called as sample statistics. So, that means, we have a variables, and corresponding to the variables we have a data. The data may be with respect to cross sectional units or time series units. So, we have a number of data points corresponding to a particular variable, and corresponding to the data points with that particular variables, we have to calculate the sample statistics. So, the sample statistic can be represented in the form of mean x bars or variance s squares. So, the we have already discussed all these statistic in the last kind of structure, but here we like to again get these parameters or the statistic values, and then on the basis of these values you have to go for some kind of further investigation. So, when you look for a kind of parameters value, that the something called as estimator of an unknown parameter, then it is nothing but function of variables, and then with the help of data we have to estimate all these values of these parameters. So, now so this the kind of examples are mean, standard deviations, variance, all these things, right. With the help of these we have to calculate the or you have to investigate the problems. So, now this is what the particular structure, investigation structures. So, what we have already discussed, it is always the game between population and samples. Most of the instances we have to draw sample from the population and then investigate the process. For instance, so here in this past case it is the kind of population structure, and the kind of sample which you have drawn from the population is called as sample statistics, and means the process which we investigate, then we will get some kind of sample statistics. So, that means technically this is the population umbrella, and few items if we take and then create a kind of structure, that is called as sample, and the sample is a part of the population, and when we investigate the population, then we have a population parameters, and usually any kind of investigation process, the population parameters represented as mean mu and standard deviation sigma, and then corresponding to a particular sample, the sample statistic will be is a x is a sample, then corresponding to x. So, x bar is the sample mean and s is the sample variance. S is then means sigma square is the kind of parameters through the sample the sample statistic will represent. So, every times our approach is to check how sample statistics are different to population parameters. So, this the validations or the problem may be authentic or reliable when the sample statistic will be close to population statistics. If not, then there will be difference, and if this difference will be there, so you have to find out against why this difference, either the pick up samples from the population may be wrong, or the population's parameters which are already available is a kind of question mark. So, the idea behind this investigation or inference is just to find out the reality and then do the adjustment accordingly as per the requirement, and then accordingly we have to take some kind of management decision corresponding to a particular problems. So, now there are two ways to draw inference from this particular process of investigation. So, the first approach is called as estimation, and the second approach is called as testing of hypothesis. In the estimations, our idea is to estimate the parameters using a sample statistics, and the process which you follow the called as estimations, and it is of two types. And first one is the point estimation, and second one is the interval estimations, which we have already discussed in the previous lectures. And like interval, what is this test statistic for interval estimation and what is the test statistic for point estimation. And in the second approach, we have to follow the testing of hypothesis, and which is actually connected with the first approach, that is the estimation. And here we like to assume that one or few parameters has some kind of specific values or some kind of relationship, and then on the basis of population parameters. So, we have to take our decisions. That means, we have to here compare with the population statistic with sample statistics, and whether there is a difference. If not, if there is a difference, so what is the kind of inference, and if there is a difference or if not difference, then what is the kind of inference. So, that means, so whatever may be the kind of structures, so we have to conclude accordingly. So, here the process will be like this. So, statistic versus parameters. So, the first one is the sample statistics. So, it is a kind of summary sheet measured, or like what we can say that mean, a difference in means or proportions, odd ratio, correlation coefficient. So, these are all represented as a sample statistics, and so this is a slight examples behind how to calculate the sample statistics. And then this is actually correlation coefficient between vitamin D and the cognitive function in the sample of 100 men. So, it is the kind of sample statistic which is represented through a particular data structures, and then accordingly we have to calculate and then compare with the population parameter. So, the population parameter is the true value or true effect in the entire population of interest. So, the classic example is the true mean vitamin D in all the middle age older people in European countries, means the men side is 62 let us say, then corresponding to these figures. So, we have to calculate the sample statistic, then you have to compare the kind of comparisons. Now, similarly, the correlation coefficients between vitamin D and cognitive functions of this particular entire zones. So, that means, here the idea is actually, so you have a kind of population figure and you have a kind of sample figure. So, you have to check how sample will be representative to your population. Sometimes sample may be good, sometimes sample may not be good. So, we like to get some kind of inference, you have to check and get the inference, and then on the basis of that you have to take the management decisions. So, now one of the procedure through which you have to go for some kind of inference. Of course, we have already something kind the structure about the population sample, then some kind of sample statistics, then population parameters. So, these are all there actually, but so far as the testing is concerned. So, we have to follow a particular test structures. So, here some of the statistic we like to use to get some inference, and on the basis of the empirical testings. So, there are 4 standard test statistics through which you have to go for these empirical investigations and then to get the inference. So, the first one is called as a standard normal distributions, that is usually called as a Z statistics, then chi-square distributions, then third one is student t distributions, then finally the last one is the F distributions. So, we have to here investigate the kind of problems on the basis of Z statistic, chi-square statistics, t statistic and F statistics. So, now we will discuss in details about all these test statistics first, then we will connect with a problem, and we like to know how this test statistic will help you to get some kind of inference on the basis of your problem investigation. The standard normal so far as the standard normal Z statistic is concerned. So, the particular structure is followed by a normal distributions, and this is what the normal distribution functions, and on the basis of normal distribution functions we have to calculate the z statistic, and it is the particular formula here. Actually the particular variable will be followed by a normal distribution with a mean 0 and standard deviation 1. So, if that is the case, then it will give you some kind of normality or some kind of pattern of the data, or so far as the distribution is concerned. So, then on the basis of this particular structures you have to calculate the test statistic and then compare with the population kind of structures. So, here then you like to know here how to calculate actually z. So, z is actually standard normal distributions, and usually the procedure to calculate the z is x minus mu by standard deviations, and mu is nothing but called as a population parameter, and standard deviation sigma is nothing but actually population standard deviations. And we like to check, we like to calculate the z, and that is what the standard normal distributions, and then accordingly we have to see the kind of the structure through which we are in a position to take some kind of decisions. So, we have already discussed the particular structure in the previous lectures. So, here so the what is the idea exactly, you have to do some kind of transformations, since it is the kind of interval game. So, we need to find out integrals, and the kind of probability between two different interval or two different range. So, since it is by calculation it is a difficult one. So, we have to follow the kind of z route, and then on the basis of z route we can get the same structures with a kind of simple structure. So, the idea is here. So, the first one is the x informations, that is the sample information. So, now it is a population mean is actually 100 and population standard deviation is 50, and then x values having 100 and 200, and that will convert into z structure with 0 and 2.0. So, that means the typical transformation will be z equal to x minus mu by standard deviation. So, that means, so this is actually the structure is z equal to x minus mu by standard deviation. So, mu is here actually mu is here 100 and standard deviation is actually 50. So, that means, so the structure will be 100 minus 100 divided by 50. So, that will give you the 0 structure, and then against 100 the 200 for x 200 minus 100 divided by 50, it will give you actually the structure 2.0. So, that means, the original values of x will convert into the z, and then we will go for some kind of investigations. So, this is how the particular structure about the kind of z distributions, and this is what the standard examples. So, what is the probability of getting a match set score of 575 or less, where population figure is mu equal to 500 and population standard deviation is 50. So, now the following transformation we like to follow, z equal to x minus mu by standard deviation. So, here so the x is actually x is here 575 and then mu equal to 500 and 50 equal to population standard deviations. So, now 575 or less. So, you can first calculate at 575, then accordingly you have to find out the particular structure and find out the probability of that particular zone only. And it is very easy to calculate, because we know that total probability is always equal to 1. So, you find out a specific value case, then the remaining structure will be calculated by 1 minus that specific probability value. So, by default it will give you the kind of inference through which you have to take a decisions. Similarly, there is another example. So, means let me first highlight you the same examples how you have to actually calculate. So, it is actually through definite integrals, and in fact, actually we need not require to calculate the definite integrals. So, you have to go for z transformation. So, once you get the z value, then we have actually the simulated z tables. On the basis of simulated z tables, you can get the particular probability, that is what the level of prediction we will get, and on the basis of that predictions or the probability, you will get some kind of inference. So, now I will give you the kind of structure here. Okay, so this is another examples, and similarly you can calculate, and this is what the structures. Okay, so the corresponding to the weight of x value 141, let us say here. So, this is 141 actually x, and then this is actually population mean 109 and population standard deviation 13, and as a result Z statistic value 2.46. Similarly, in the second example, so here x will be 120, and again we will follow the same population parameter mu equal to 109 and standard deviation 13. So, it will give you 0.85. So, now we will check what is the corresponding to the z. So, what is the probability? So, you again there is no requirement to find out the definite integral. So, you have to just go to the z tables and then you have to report the probability. So, that is how the inference you can draw from this particular structure. So, this is what the standard z tables. So, usually the particular structure is like this. So, so this is what actually the kind of z structure. This is what actually z structure, and then so for instance, let us say 1 point actually 401. So, 1.401, this is 1.4 and then this is 0.1. So, that means 0.98 to 9807. So, that means 92%. So, likewise, when the probability actually say to z value is equal to 2.5, then the probability value will be 0.9938. So, that is how the particular structure. So, it will start with 0.0. So, that means the entire tables you will find the values of probabilities only. So, the usual procedure is having the population figures and the kind of x specifications. So, you have to first calculate the z value. So, once you get the z value corresponding to the z value, you can know the probability, that is the kind of percentage through which you have to get the inference, and then you will conclude as per your management requirement. Okay. So, next so this is actually this classic examples which I have already highlighted. Okay. So, this is 1.5 1.51, then this will be coming 0.9345. So, likewise you can calculate for other values of the z, and the second distribution is called as chi-square distributions, and here z we have already reported that x minus x bar by standard deviations, or in other words z equal to x minus mu by standard deviations. So, now, so what will you do? You are just squaring the z statistics, then you will get x minus mu squares by sigma square, and the z square is nothing but actually chi-square. So, what means the question is what would its sampling distributions look like. So, this is actually the kind of example, and this is the usual structure of kind of chi-square distributions, and your idea is to minimize the minimum value is 0 and maximum value is infinite. So, that means most of the values are between 0 and 1 and most around actually 0. So, that means actually corresponding to this z. So, the idea is actually z and chi-square are actually very close to each other, but just you have to check the kind of structures, and then accordingly you have to calculate, and then you go for some kind of inference. Okay. So, this is what the usual procedure of for a individual kind of problems, you have to calculate the chi-square value, and again so like z tables, you have actually chi-square tables, and once you get the chi-square value, so you can go for some kind of probability, and that is the structure through which you will get some kind of inference. And one of the linkage or understanding you may hear that when your sample size will be actually large, that is that will be followed by a concept called as a degree of freedom, then your distribution will be skewed to normal. So, that is what we have already discussed through central limit theorem. So, every time when you will go for some kind of investigation, that is the problem investigation. So, to get inference or to get some kind of in depth kind of findings or some kind of output. So, your sample size should be strong enough. It is not actually statistically a kind of true or statistical requirement. So, it will give you enough exposure to go or to go in depth about this particular problems, and then you will get solid inference, and on the basis of that your management decision will be very perfect. So, that is how every time the suggestion is that you must have actually a sufficient sample points or some sufficient data, so that you can investigate the problem in a kind of more attractive way. And then another statistics called as student t distributions. So, here the question is, standard question is, what if sample size is less. So, we have actually two different sample structure, one is called as small samples and the second one is called as a large samples. So, usually the cutoff rule is 30. So, any problems having greater than 30 means it is usually called as in a large sampling case, and when your sampling is less than 30 it is called as small samples. But what the question is not actually whether it is the structure less than 30 or greater than 30, it depends upon how many variables in your system, and that we will discuss in details later stage depending upon a particular variable structure. So, what should be the optimum sample size. But in any case, so the usual structure is that if you have a large sample, then your accuracy will be very high. It is not statistical accuracy, it is also problem accuracy. Usually if you have more data points and more informations, then obviously the inference will be more attractive and inference will be more efficient. So, that is how every time you look for more data points, and that is what we call as more sample size. So, if your sample size will be big enough for large one, then obviously statistically it is very true, or statistically you are in a right track, and accordingly your investigation process will be very effective to get some kind of better management decision. And sometimes you will find two different situations. In one case, sometimes your population parameters are known, and sometimes population parameters are not known. So, when population parameters are known, then you can use the Z distributions. If population parameters are not known, then the particular statistic will be followed by t distributions. Here you have to find out first the parameters value, and then on the basis of the parameters value you will get the t statistics, and again you will go for as usual drawing the inference, right. So, so this is actually, so one of the particular structure is called as t distribution, and in the case of t distributions your whole idea is to get the actually parameters value first, and then you will connect with the inference kind of requirement. And sometimes what happen your sample statistic may not be close to normal distribution, and or it may be nearly close to normal distributions, but again the suggestion is that you increase the sample size, so that it will be close to the normal distributions. And this is how, when the distribution is not actually normal, then you have to calculate the t distributions, and the particular t statistic formula is here x bar minus mu by s by root n. So, s is actually a sample variance. So, that means sample statistic will be represented as here the parameters value. So, it is actually in the case of z, it is x minus mu by standard deviation, that is actually the standard deviation is population parameter, and it is known to it is readily available, or it is known. But here in this case, so the standard deviations is not known. So, it will be calculated through sample information only. So, that is how the kind of sigma is nothing but actually s by root n. So, that is the adjustment factor which you have to do here in the case of t distribution to get the particular inference as per your problem investigation. Then in the so, the details about the t distribution is like this. So, let me take you to this particular structures, how you have to calculate. So, I have already given you the idea x minus mu is actually z statistics, and then so t distribution has well connected with the z distribution and chi-square distribution. So, this is what actually the typical linkage. So, this is what the typical linkage. So, the t distribution with k degrees of freedoms, where z is the standard normal distributions and chi-square is the distribution with the k degrees of freedom, and k is the degree of freedom for chi-square distributions. So, that means there is a kind of proper linkage. So, once you get a particular distributions, so then obviously you can connect with other distribution and get the inference as per your problem requirement. Okay. So, now I will take you to the kind of structures to know how these distribution are well connected with sampling structure. Every time when you are going to investigate any kind of problem, your your requirement is that the distribution should follow actually normal, because it is the best distribution so far as the investigation is concerned. And what we have already discussed that or the typical suggestion is that every time you must have high sample size or high degree of freedom, and which is the difference between sample size and the number of variables involvement or number of parameters involvement. And here the typical example is you see here there are three shapes of the distribution, and a typical shape is represented by three different colors altogether. So, the green colors, then the blue colors and the black colors. So, here so degree of freedom is 1, degree of freedom is 5 and degree of freedom is 25. So, that means if you put in other words, so sample size increasing from one point to another point, then when sample size is increasing, then by default degree of freedom will be increasing. So, when sample size will increase or degree of freedom will increase, then what is the typical structure of the particular distribution. So, now see here. So, this is the green where your degree of freedom is equal to 1, and here degree of freedom is equal to 5, and here the degree of freedom is actually degree of freedom equal to 25. Now, there is a red color graph, and that is actually standard normal. So, that means actually 1, 5, 25, maybe it is actually degree of freedom 50 or something like that. So, that means when sample size will be more and more and more, then your distribution will be, every distribution will be close to the normal distribution. So, since normal distribution is the symmetrical distribution and best distributions so far as a problem investigation is concerned, or to draw the statistical inference. So, every time the idea is that you should have a enough sample size to represent the particular fact, or to investigate the process and to get the best inference or the best decision as per the problem requirement. Okay. So, this is what the typical structure. So, the t distributions another if you make another look. So, this is actually t equal to degree of freedom 5, and when degree of freedom is 13, and here actually when actually it stands towards infinite. So, that means it will give you what we call as normal distribution, and that is what we call as bell shaped kind of structure, or in other words in statistical angles we call as completely symmetrical distributions, where mean, median and mode will be coincide. In other case, when your sample size will be less and less and less, then the symmetrical distribution will be moved toward some kind of skewed distributions, where mean, median, mode will not be a kind of same. So, it will not coincide if sample size, that means there is a high chance that they will not follow the symmetrical distribution if your sample size will be very less, but the same structure can be moved toward normal distribution or symmetrical distribution, where sample size will be a substantially very high and indefinitely increasing. So, that is how the structure you have to follow to get some kind of So, this is the standard structure of t tables. So, we have already connected with the z tables, and this is the kind of structure about the t tables. In the t tables, the right hand part is nothing but called as probability kind of structure, and I will let you know the details about this particular structures when we will go for hypothesis testing in details. And here in this case it is the kind of degree of freedom. So, a degree of freedom actually if you start increasing, or when sample size will be increasing, by default degree of freedom will be increasing, provided a particular variable is constant, or set of variables will be constant. And then once your degree of freedom will be increasing, then your some the t values will be start declining over there. So, this will give you some kind of setup through which you can understand that when your sample size will be increasing or degree of freedom will be increasing. So, it will give you better kind of structure to get some kind of better inference, and then you have to take a decision as per your problem requirement. Okay, so this is what actually and in the normal and t distributions. So, this is actually the typical structures with different kind of structures. You starting with degree of freedom small to large, then your distribution will be follow a kind of symmetrical. So, you will see here the kind of movement. If you will follow this particular movement, so this is the kind of movement you will follow, it will give you some kind of towards normal distribution. This gives better picture, and this clearly highlights that when your sample size will be more and more and more. So, it will follow the normal distributions and the distribution which can give better inference for a particular problems. And the last one is actually called as F distributions, and it is the ratio of two chi-squared values, and that is what the particular structures. It is the chi-square of the first case and the chi-square of second case, but corresponding to t and chi-square. So, F value has a 2 degree of freedom. So, the first degree of freedom with the upper one chi-squares, that is this part, and the second one is degree of freedom is with respect to the second chi-square. So, as a result, if you go to the F tables, you will find two different degree of freedoms, and then corresponding to a particular probability you will get a kind of critical value. So, let me show you how is this particular structure altogether. So, F distributions, this is the details about the F distribution. So, so the look of the F distribution is like this. So, here, so this will follow the kind of degree of freedom of the first case and the degree of freedom of the second case. So, now in the hypothesis testing structures, you have to first fix up the probability levels, then corresponding to the degree of freedoms. So, F critical will be calculated, and on the basis of F calculated and this kind of sample kind of structures. So, you can get to know what is the exact structures or what is the exact inference through which you have to draw and conclude as per your problem requirement. So, with this I will let you know that in any kind of investigation process. So, you have actually couple of test statistics through which you have to investigate the problem and get some kind of better inference, and on the basis of this inference you will take some kind of management decision. So, I strongly suggest that there is a very high linkage with all these distributions, but once you acquainted with one particular distribution, then by default you will acquainted with other distributions, and all the sometimes in a particular problems you have to choose a particular distribution or test statistic through which you can get you can investigate the problem and to get the inference. And some test statistics are it is a kind of problem specific. For instance, F distributions, if you have it means the requirement of F distribution that you must have at least two variables in the systems, but that is not the case in the case of let us say Z or chi-square or in the kind of t. But in the case of F, your requirement must be with two variables, then you like to know what is the actually within and between difference with respect to their sample point and the corresponding the variable specifications. Likewise, you will find plenty of structure through which you can investigate the problems, and then you will get some kind of inference. So, that means in the inferential analytics we have a typical structures. So, it is the discussion is like this. You have to understand the sample versus population, then sample statistic, then the population statistics, then every time you have to check the comparison between sample statistic and population statistic, and then so far as inference and drawing conclusion is concerned, then you have to connect with a particular test statistic that may be with respect to Z statistics, T statistics, chi-square statistic and F statistics, depending upon the kind of problems, and then the kind of sample structure, and on the basis of that you have to get you have to go to investigation process, and accordingly. So, you will get some kind of inference, and on the basis of that inference, So, obviously, the problem the guy, I mean the management can give you some kind of structure through which you can take a decisions. And with this we will stop here, and thank you very much. Have a nice time.